the Mesonet is 145 stations throughout New York State. We tried to get 2 in every county. You win some, you lose some. All of the stations that we have were pieces of land that were donated to us by either private or public entities. So it could be somebody who owns 100 acres of farming land and says, yeah, you can take a chunk of my land to put your weather station on, to public colleges and schools, elementary schools. We have 4 elementary schools. We have 8 SUNY colleges that have these weather stations on their grounds. So this is just a quick map of showing where they're located throughout the state. This one here shows the exact locations of them with the closest town or village or city. As you can see, the different dots signify different types of focus for those stations. Some stations have more instruments than others. For example, if we look down towards Owego, you can see they have a regular Mesonet station. They have what's called a flux station, which is instruments that determine the humidity and the wetness of the atmosphere up to and including 5,000 feet from ground level. And then we also have what's called a profiler station, and that lets us know the heat flux transfer between the ground and any buildings, and also between the ground and space. So that gives you an idea of the difference in Owego. And those are similar throughout the state that have those corresponding color-coded dots. If you're colorblind, let me know, because I could be more descriptive in that. All right, so this is a station. This is what the regular Mesonet weather stations look like. This one's out in Clymer, New York. It's literally steps away from Pennsylvania. So that tells you we stretched from out west along the Lake Erie, Lake Ontario. We go up north through the Adirondacks. We have a site that's inches away from the Canadian border. And then we go down through parallel to Vermont and Massachusetts. We tried to get sites that were representative of a 15 to 20 kilometer area around where the site's going to be. So for example, if in 20 kilometers you have a lot of hills, then we wanted to get a site that was representative of that. And the opposite is if you have one where it's mainly flat, then we wanted to put a site there. We used the World Meteorological Organization's site guidelines for all of the sites. And so that became a bit difficult when we had to talk to some site hosts who really wanted a site, but we had to tell them no, because your site does not meet the qualifications. To give you an idea, for every site that we had on average 15 to 17 people we had to say no to. So 25 times 15 gives you an idea of how many people really wanted to be a part of it. There was no financial gain or loss for anybody. So on that aspect, it's really just donating your land. And we have the right of use to go from the main street to the property where the station is located.
Dan, why can't you put up more sites? Is it costly?
To put more sites up? Well, you know what? It's not costly, but right now we're in the phase of essentially pay to play. We do have 2 sites that are going to be going in down in Nassau County. When the original 125 were installed, we were able to install them from a grant from the federal government and New York State that came out of Hurricane Sandy, destroying many locations on the eastern seaboard. So in terms of climate change, this project, my job, is directly tied to that. So the two sites in Nassau County has said, we will pay for you guys to install them. We will pay for everything to keep them maintained. So those are the only two locations that have come up and said, yes, we'll pay for everything. A lot of other people have said we will pay for bits and pieces. And so it just comes to us finding the required other end of the financial side to make a site and to maintain the site. The biggest cost is in maintaining a site, not necessarily putting one up, because you don't want to put something up and then it fade away into oblivion and not get used. And that's really not what we want to have happen.
Do you end up with like getting diminishing returns if you have so many in a certain location?
Well, we do. What we did was we looked at a couple of sites, a couple of locations, and we chose ones that maybe were not the best location, but they gave us the most important data. For example, we have a couple of sites out west, and when I say out west, I mean out towards Batavia and down 390 to Olean and out that way westward. We have a couple of sites that we picked those because those would most heavily impact the residents who live in that area. One site in particular is located on the top of a hill. It's the highest elevated site we have. And we chose that one because most people use that as a telltale sign of what's happening outside where they live, in that 20 or 30 kilometer region. So in a sense, we had some play with the requirements of putting the site in, but not too much. But we did look at the aspect of how many people would be affected, dependent on which location we were able to choose for a site. So as you can see, these are the instruments and everything else that goes on to the site. The site is powered by solar panels. 24 volts goes into the site. Unregulated, we found that if we regulate the 24 volts, we ended up having some issues with a few of the instruments, simply because they're on a static energy draw, and in the wintertime, they might not operate as best as they should. So we became unregulated at all of the sites, and that helped out a lot with our data retention from all of the instruments. We have two sites that are powered off of satellite communications. All of the other sites are powered through cell towers. We have two antennas that, depending on the season, we get better return from. So that's how we send the data. All the sites get the data sent to University of Albany. That's where the main office is. And so we have a good retention rate. And every day we obtain 99% of the data. There's a site down in Deposit that, because of its location, it's difficult to get a live stream of all the data. So that site comes through every 2 or 3 hours, that data. And so that's why I say 99%, because it is that one site in Deposit just off of Route 10 in the reservoir. So taking a look at some of the stuff that we encounter, we have to, the fans, obviously, when they're running, they suck up a lot of debris, bugs, insects. We've had bees that get sucked up in there. We just have to clean them out. We clean all the instruments at least twice every 12 months. We try and get to them quickly thereafter. What we do is we just open all the instruments up and we clean them. Some of them with soap and water, some of them with canned aerosol spray. It depends on what the instrument is, but by and large, we just want to make sure all the instruments function as they should. We do take all of the instruments out in the fall and we place them with instruments from the lab that we have tested to make sure they're true and accurate. So every 12 months, we have new instruments going into into the field. And then we take the old instruments up and we test them, and then we keep them for the next rotation or any special projects of a short-term nature that we need to complete. Um, a lot of the instruments, they're pretty much you take them apart, you clean them, you put the same ones back in. We do have some wear and tear, as you would imagine. These things are out in the field in various conditions, and so some of them do break, some of them need fixing before they break, a lot of preventative maintenance. And so what we do is we try and jump on that as quickly as possible. The most robust instruments that we have are the lane gauges and the wind monitor that you're seeing on the screen now. With these instruments, we can actually um, calibrate them in the field, and then we put them right back up onto the tower. So this is the only instrument that we do not take back to the lab after we fix, because it's just that much easier to fix it in the field. We have found various other ways to do this one, and it's just most easiest in the field. Um, Here's the rain gauge at two different sites. The one with the Windex on the bottom, that one is in Claryville, New York, downstate a bit. And this one on the other side with the corn is out by Rochester. So that gives you an idea of the two different types of settings that these instruments are placed in. We have noticed that some of the sites do record a higher relative humidity value when they're placed in places that are surrounded by, as you expect, corn, or just simply higher than the instruments themselves. That hasn't deterred from the data too much. It's not like we have they're recording 87 and then the closest site is reporting 70. It's really only a 0.2 to 0.3% difference. So 87 versus 86.3 or so. That type of thing. So it's not a huge game-changing value. We do have the most sensitive instrument is the rain gauge, and what happens is the rain collects on the top there. There's usually a bucket, but I took that off so you guys can see. It collects on the bucket, and then the bucket pushes that weight down, and then we determine how much liquid is inside, and therefore how much precip has fallen, be it snow, sleet, rain, hail. We have also found out through trial and error that this instrument is extremely sensitive. And so it's probably the one that we visit the most often to make sure the data is correct. I would say on a given site, we probably go to this instrument 7 to 9 times every 6 months.
For a second, what do you, why would we want to know the weight? That's just confusing to me.
Right. So yeah. So I'll go back. So what you would want to do. So if you were just to measure the height of the rainfall, what would happen is you would have people that have different sized rain gauges in various locations. And so the American Met Society and the WMO had said, okay, these are the standards that we will have both in the States and the standards we have across the globe. And so in order for us to meet those standards, we had a choice. We could go with a couple of different options. And we chose this one because it is, like I said, the most sensitive, but it also provides the most real-time data for people to use. A lot of rain gauges, you just measure the height and off you go. With this one, you can measure how heavy it is, and that way you can tell, okay, is it rain falling? Is it freezing rain? Is it hail? Or is it just melted snow that has accumulated inside the instrument? And those are those 4 reasons were what kicked us over the edge to buy this instrument, as opposed to another type of rain gauge that normally you would see, say, at the airport, or you might have behind your house if you're so inclined. So it gave us real-time information on the type of precipitation, and so that's really what caused us to say, okay, let's pick this instrument. And because it is so sensitive, you have to give it a lot of TLC. I spoke a little about the relative humidity. So on the left, you can see the instrument that we use to measure humidity. It also measures the temperature, but we decided that we would just use the thermometers um, at both 9 and 2 meters instead of the thermometer inside of the HMP to give us temperature instead. So what we have here is we put the humidity sensor inside what's called a non-aspirated shield, and pretty much you just want to have the wind blowing through it all the time. You don't want to force it into it like we would force the wind up into the fan and the thermometer. You get a more true, accurate reading. Since it is almost probably, hopefully, going to snow this weekend, we put the snow sensors out into the field. In the summertime, we use them to determine how high the grass is. And then if it gets too high, we have to go out and cut the grass. We usually visit a site in the summertime at least once every 3 weeks to cut the grass. So that's a lot of driving just to cut the grass. But while we go, we also clean a lot of the instruments in case anything's come on top of them. In the wintertime, of course, it's more useful for this instrument. So it's what it does, it sends a laser down to the ground. We have a white snowboard. I'll show you in the next clip what it looks like. But we have a white snowboard, and the instrument measures the time it takes from the laser to go down, hit the snowboard, to come back up. The money piece in the instrument is on the far right corner. That's where we have the most problem in terms of blowing snow and drifting snow, because the instrument will record the bunch of snowflakes that are closest to it, as it should. Unfortunately, that won't be exactly what the snow depth is at that site. So usually after a snowstorm, it takes anywhere between 6 and 12 hours to get the actual snow depth. And then we go back in time to correlate that with how much snow fell over a given period of time. It doesn't really take that long to go back in time and correlate that with what we have on the ground now, but a lot of sites do have some heavy drifting and blowing of snow. And so we have to be pretty meticulous in determining how much snow actually fell in a specific time frame and how much is still on the ground. And it didn't get blown away and swept away. So as I said, here's the snowboard. In the fall, we go and fix it. We make sure that it's level. Obviously, if it's not level, it won't give you any good data. The snow will melt off and run off. But for the most part, a lot of these have held up over the past 3 seasons. We're looking into replacing them in about 2 seasons, and then COVID hit. And so, we might ramp up the replacement of these over other types of choices that have to be made. Because in the wintertime, this is probably the most important instrument that we need. And so in that whole season, if we have this instrument go down, it'll be very problematic for us and pretty much why it's out and therefore. We do collect the solar radiation from the sun. We do make sure it's level. Sometimes it gets out of level and we can actually see in the data. So we do every now and then periodically fix it. But this one we can go ahead and make sure it's true and level. Usually twice, like I said, those cleanings twice a season. We go and make sure it's okay and level. We did use this in the eclipse that happened a couple of years ago. We actually could watch the eclipse from different sites, and we pulled up this data from the solar radiation. You could tell where the eclipse was happening and the time it happened and when it stopped at different sites, because it was really cool to watch, because you could see the solar radiation go up from, it was at like 800 or 900, and then it went down to say 200, and then it went right back up 15 minutes later to 800 or 900, and we could track that, and we have it on a moving scale on a movie, and you could see throughout the state all the radiation levels go down, and then they came right back up as the sun came back out. And it's like 2 o'clock in the afternoon, right? So it was really cool to see that throughout the state, not just in one location. But that's a whole different presentation that would be really cool. I gave that presentation to two schools. One was down in Austin, Texas, and the other one was in Georgia, outside of Atlanta. And those kids were really surprised at how much less sun we get up here than they do down that way. So that was a really cool, and that was to, let's see, that was the first one was to grade 7 and 8, and the second one was to grade 11 and 12. Those science classes. And so with the 11th and 12th grade, I was able to dive into more of the science behind how that instrument does what it does, and why it's important to to get that data. So that was cool. With the 6th and 7th graders, I was able to just kind of touch on those and just pique the interest in a general way. Every site that we have does have a camera on it for two reasons. Everybody likes to look and see it, what's the weather's going outside the window, and so we have 125 of these windows. The second reason is for security issues, just to make sure nobody comes in and screws around when they shouldn't be there, that type of thing. We haven't had anyone do that, but you always want to make sure you cover the the instruments and all of your time you put in. Each station has 3 soil sensors, excluding the ones that we have down in the 5 boroughs of New York City. Because those sites are on top of rooftops, and nobody wants stuff sticking through their ceiling as they look up during the day. So we don't have any soil to give you in New York City, but the other counties, we got that covered. They'll place at 3 different heights: 5 centimeters, 15 centimeters, and 45 centimeters. And so they're pretty robust. We've only had a few of them go down with no reason. A lot of times when they go down, it's because of mice issues or of some other type of problem. The wire gets loose, or an animal gets in and just kicks it like a fox or something. So it's not, they just dig for it and they see it's not what they want, so they just walk away. But they have, caused an issue with it. So it's not. This instrument's not. We don't have to really see this one too much. It's not a frequent flyer like the rain gauge is. So on the right-hand side, you can see this is what the main hub of each station looks like. It has a data logger, which is what that blue cord is plugged into right in the middle of the screen. On the bottom is all of the different electronics and wiring that goes into each of the sites. On the left picture, you can see is the barometer. All of the sites are the same on the inside. So when every tech goes to a site to see to fix something, he'll see the same thing at every site, and that's to make it uniform so that nobody has to go to a site and spend 25-40 minutes figuring out, well, where does this cable go that I have to fix. So it's conformity. People like things neat and tight as best as possible. And here's just a close-up picture of the data loggers. We actually have 2 of them. On the left is the one that you saw in the picture previously. On the right is just a new, more improved model of the data logger. And, it's obviously smaller than the one on the left, but, the main picture here is just that it's the new and improved model, so it doesn't do anything more than the other one. It's just a lot tighter and more. You could put more things into the enclosure, but it's just the newest model that came out. Now I just leave this with you guys. I'm going to switch over to a different screen, but before I leave, the shot there on the left with the owl, wants you to ask some questions. He is there to prevent the mice that really love to chew all of the cables at the sites from doing that job. So he's at one of the sites. He's been there for about 18 months, and he has not let one mice go past him. So that is a very good thing. We named him Henry because we needed a good name to call him, and his name is Henry. So The picture of the cow on the top right, that was a new calf that was born. We actually watched it on camera. You could see it out in Cincinnati. That's where this site is. So that was pretty cool to watch that if you're into that stuff. And the picture on the bottom. So the rain gauge has a lot of these metal slats that hang that surround it, as we saw in a couple of pictures beforehand. And of course, those slats, they're outside all the time. They get broken. And so then just one winter storm, this one's in Batavia, in just one winter storm in about 6 hours, we had all of those slats get broken. And so we had to go out and fix them. If we didn't fix them, then we would get the precipitation data that would be erroneous because the rain would now not just come from above, but it will also get blown in from the sides and below. And again, the rain gauge, I gave a presentation just on that to 10th graders through 12th grade. So 10, 11, and 12. And that was in a school in Rochester, Minnesota. And so that was a fun time explaining to them the whole science behind that. And that was at 45 minutes of me talking and them listening, and then about 20 minutes of them asking questions. So that was pretty cool to get the interaction between the students and what we were talking about. So let me switch over to a different screen to kind of give you guys a different view of more of a case study, if you would say, of how we would use the data in real time. So let me pull that one up for you. Let's see here.
Oh, you guys already know a lot of this stuff. This is all fascinating to me.
Hold on. No, don't want that. Okay. All right. Pull this one up. Oh, dang it.
So one of the things as he's getting all things together, we were discussing is talking to your kids about jobs and what it's like. And so, kids might say, oh, I want to go into meteorology because I'm interested in the weather, but they may not like actually being outside. And so, Dan was saying he does a lot of travel, or actually maybe you'd like to be outside. Dan is spending a lot of time traveling and having to spend time in hotel rooms, and you're away from family. And
Right. So yeah. So and jumping on that one. So yeah, I guess the one of the things that Aaron and I talked about, and if you're looking at job prospects for your students, which is one thing, this job was not available. Less than before Hurricane Sandy, right? So 2013 Hurricane Sandy came in and destroyed a lot of stuff. So this job has only been open since then. Professionally before this one, I was down in Texas, and I was working for the state of Texas as a air quality reviewer of oil and gas permits. So the gas companies needed to make a change to their industry and their buildings, and they would say, "Can we do this?" And I'd be one of the guys look at it and say yes or no. Before that, I spent 5.5 years in Canada, and I was a meteorologist up there. Behind the scenes, I was working at a TV station, but what I did was I gave a lot of consultation to various organizations, talked to the Greater Toronto Airport. In fact, I was on call with Air Force One when then President Obama was flying into Ottawa. So I was on a 4-way conference call with them and the Ottawa airport, NAV Canada, as well as the U.S. Airports. So that was cool. I also talked to a lot of the ministers of transportation in terms of winter weather, talked to a lot of the marine community in terms of boating on Lake Ontario. So we had a lot of clients who dealt with a lot of the weather information, and it was always a lot of fun to kind of get the background into what information they need the most. And so with the job I have now, I travel. I go about, before COVID, I was doing close to 500 to 800 miles a month, just driving in the truck around the state of New York. Um, because of COVID, I've cut that down to about 1 to 300 a month. So yay COVID. Um, the job has not changed during COVID. I'm still essential. What has changed is the amount of miles that I am allowed to log on the road because of COVID. I do a lot of driving by myself and I stay in hotels, but because of COVID, some hotels have closed for good. And so a lot of restaurants as well have closed for good. And so the planning has been, okay, can I get from my site, from where I live, to a site in less than 12 hours? And if I can't, how did I piggyback that onto going to a different site? My region of coverage is Interstate 81 all the way west to the Great Lakes. So ponder that geographical distance. We have two other field techs, and their area of coverage is if you draw a line from 81 all the way east to along 90, of course, all the way east to Massachusetts and go north. That mm, polygon is one field tech, and he lives in the Adirondack Mountains, and so works well for him. The other field tech is New York City, Long Island, Staten Island, all the way north up to Albany, and then west to 81. And he lives in Albany, and so his traveling to the city has been greatly reduced because of COVID. But there's only three of us who travel across the state, and so when one person is sick or on vacation, we really have to time that out to what field tech can get there the best. We do go out in all types of conditions. We go out when it is really hot. We go out when it's really cold, snowing. We don't go out when it's raining because electricity and rain does not mix. So we don't go out then. We just hold off and go as soon as we can to sites if it's raining at a site. We have gone to sites, and like I said, we have seen mice at sites. We have seen owls. We have seen hawks. We've had bees. We've had to buy a bee suit because of the bee nests that build at the stations. Mind you, these stations are in the middle of a field, right? So there's nobody going around them all the time except the guy in a tractor. And so the bees have all the time that they need to build these huge hives. It's quite scary when you show up there and all you can hear is the buzzing of bees and not the fan that is blowing in the 2 meter temperature. That tells you there's a lot of bees. We have found hornets. Interestingly enough, and I didn't know this, that mice can actually live on top of a bee's nest. That freaked me out when I first saw that. So if you have any students who have allergies to bees, fear not. We have one field tech who is allergic to bees, and he carries 4 EpiPens with him all the time, 2 in his jacket, 2 in his pants. So if he ever gets stung, he can stab himself with hopefully whatever's close. We have had to go to sites because, and I kid you not, cows have broken into a site and they have destroyed. Oh, that was a bad day. They destroyed all of the instruments that, pun intended, from cow height down to the ground. We had a cow that decided to give birth in the rain gauge, and so that calf was a bit stuck there for a while until it could get up and move by itself. We had the farmer come out and try and help us, but I told him, I said, look, if you can't get it, I'm not touching it, and that's fine by me. So he coaxed the calf out as best he could, and then about 2 days later, I went back to the site and just put everything back the way it should go. So that was exciting. Let's see what else. We've had a couple of people who want to know more about the Mesonet, and they've been pretty curious into not asking us questions but figuring it out on themselves. And so they're no longer allowed to go to those sites. We've banned them from those sites, and I say that because it's important to know that anybody can go and see the site, but it's on private property. And so they actually were trespassing. So we caught them on camera doing things they shouldn't be doing, and we got them. But that's just what we have in this day and age. So the freezing fog. So everybody knows that fall is the best time to have huge temperature swings across New York State. It doesn't really matter where you are. And so I'm going to show you, this is a presentation I gave to 11th and 12th graders. Let's see, what today's December 3. So I gave this to them 16th and 17th of November. So about a month ago. And these students, let's see, the first group of students was in Schenectady at Schenectady High School, and the other group was down in Kingston. And so it was two hit on one day type of thing. So just quickly, this is how fog forms. I'm not going to, you guys can read it. I don't want to be rude to you guys, but generally when we give these presentations, we want to begin with a general science knowledge of what we're talking about so that all of the students involved can see, okay, this is what's going on. And since we all know that students love to read what's on the screen instead of listening to you talk to them, I usually let the students read on the screen and then kind of hit the highlights. So for this one, I want to hit the highlights of the fact that there was fog, the temperature was below freezing, and that could cause a problem in many locations, especially during this time of year being autumn. We tend to have these occur more often than are recorded. With the Mesonet, though, we can actually say, okay, this is what the Mesonet is built for, is to show these local micro scale type of phenomena that other people knew happened all the time, but we have the data and the science to back it up. And we go from fog to, okay, this is freezing fog. And everything is the same in freezing fog as, say, regular fog, but there were some differences that do crop up. Everything has to be below freezing. We have the same type of visibility issues. We have everything that gets coded in fog could have freezing issues, okay? Like a vehicle, your bike you leave outside, your house, anything that you have. So the National Weather Service out of Binghamton actually put out a freezing fog advisory based off the Mesonet data. And you can see on the picture there, I tried to highlight it best I could, but the white, all of the white that is in between the pink is fog. So there's the fog you can actually call the valley. And if you see the bottom point of the arrow and you head west, you can actually, that's actually Interstate 86 / Route 17, because that is all built in the valley. And you can, as you drive on that road, when you have these conditions and you go up and down the hills on that road, you can actually look around and you can see the hilltops peek out. You have the same or the similar idea when you're traveling from Oneonta to Albany on 88 and you get to Cobleskill and you climb up the hill in Cobleskill and you hit the Howe Caverns and you're going towards Central Bridge. And as you drive towards Central Bridge, you look to your left, which is north, and you can see all of the fog in that valley, and then you can see everything around it. And that gives you an idea of what was happening in this case on this day. So here's the dense fog statement. The National Weather Service said, we need to let people know about this, and this is what they issued. And it was for, if you take a map out and you check off all the counties, it was along, Route 17, and then they put Bradford in there to help out, but Bradford is a bit east. But pretty much all along the Route 1786 road, all right? To give you an idea of where we're going to talk about, we're going to look at some places right here, just outside of Watkins Glen. And I chose these two stations because as the crow flies, they're the closest stations we have to each other, but they're also the most elevated dependent stations that we have in the Mesonet as well. As you see here, it's about 14 miles between Tyrone and Burdett as you head east. Tyrone is built, it's an open level field. There was the Tyrone Fire Hall that said, yeah, you can put a station at this place. That's great. Do it. And Burdett is on the top of a hill, and it overlooks Lake Finger Lake, Seneca Lake, and Watkins Glen. So it's a really picturesque site, but it's also a good example because one's the elevation is so drastic over a short distance. So here we have, so if you were to request the data from the Mesonet, you could get it in two ways. You could get it here in a graph form, and then if you get it numerically. I chose the graph because it could give you, in this presentation, it gave the students a bit more things to think about and just to analyze and to say, oh, you know what, when we get taught this stuff in school, I should probably pay attention because here's somebody who uses it in real life, you know, with that type of, to kind of mesh it all together. And in true science faction, I do tell the kids that, hey, the temperature of the degrees Celsius, so when you see it's 24 Celsius, that doesn't mean it's still below freezing. That means it's a lot above freezing, okay? So do the math, 24 times 2 is 48 plus 32, you know, that tells you the Fahrenheit number, folks. Some of the kids don't quite grasp that, but that's okay. And here's the other site showing the same thing. As you can see, very different graphs are shown in lines, but the point I'm making here is I do show the graphs instead of the numerical picture so that the students kind of pay attention and look at it. But I'm going to zoom in on the day in question, which is Friday the 13th in November. So on your left, you have Tyrone. On the right's Burdett, the other side. As you can see, one site's about 1,200 feet above sea level. The other one's close to 600 feet above that. So it's 860-ish. So it's a huge elevation difference. And what that happens is when we had this fog issue on that Friday, I was actually in Watkins Glen. I had been at Tyrone the day before, and I stayed in Watkins Glen. And then so I drove to Burdett, and I had to wait. I couldn't get to the site and do what I had to do until the fog had lifted for two reasons. Because it was really cool just to see the fog lift as a scientist. That was pretty neat. But for the other reason, more importantly, every time we go to a site and we open up and say that we're at the site, all of that data gets flagged out as not good data. And so I didn't want to have that be on my shoulders to say, hey, I was the one who screwed up not getting that data for that day. So I waited. So anyway, so we have two graphs here. Both graphs are the same. I just cropped them from the two slides we saw ahead of us one. And so what we have, the green line is the temperature at 2 meters, and the black one you can see is the temperature at 9 meters. And so on the Tyrone one, you can see the temperature drops well below zero, almost hitting -4 Celsius. It ended up hitting 3.8, in case you're wondering. And so what happened was we took a look at that, and then I looked at Burdett, and I said, hey, wait a second, you know what? Tyrone went down for a good 7 hours, but Burdett only went down for about 3 hours, close to 3.5. So what I tell the students is that it's just a huge elevation dependent scenario where you have one site and another site, 14 miles apart, 12 miles difference as the crow flies, but they give you very different readings on the same day at the same time. And so kind of, showing the students this is what could happen. And so we just want to make sure that when we have all this data, that it can be utilized the best that it can be. And one way we try and do that is through students. So we say, okay, look, this is something you could look at, and you take the stuff that your teachers teach you and you use it in real life. And this is what you can do with what you're taught. Sometimes the students might not grasp that. I had one student who say to me, Mr. Johnston, he said, I understand you're showing us these graphs, but you know what? I'm just not getting it. And I said, okay. I said, what don't you get? He says, I don't understand why we can't have more information in school that is from what you guys do on a daily basis. And I said, well, that's not, I said, well, first of all, thank you, but that's a teacher thing. That's, but it's true. It's difficult to 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 get the information out so that you as teachers and administrators can utilize it as best as you can, because we all know that a student gets a concept, but most students get that same concept if they can kind of see it in real life. And we try, and we have, was talking to Aaron, and we have a lot of presentations that we could give for you guys, that would try and bring that home to you. And so to kind of to mesh it together to say, hey, here's what we can help you with. Um, and that's the focus of the Mesonet, is to get the information to the public. We had a couple of cases in the summertime where you could actually track the wildfires in California, and they moved east rather, and they ended up lowering a lot of the temperatures for the couple of sites across the state by 3 to 5 degrees. I mean, it was a lot. And then in previous years on the same date, so that was pretty cool to watch. We have watched forest fires as they come from Canada and move their way south. We have watched, this is a picture of a thunderstorm. I was out at the site, and this is the Bodette site. This is a couple years ago, but I was out at the site, and I watched the thunderstorm in the picture come towards me. And we have a time lapse video of that thunderstorm coming towards us. So those things are, and we would like to do a lot more of. One of the professors has taken our data and clips and has shown it to an intro meteorology class for non-science majors, and he has taken photos at the sites of someone like this, but not this one, and he has said, okay, this is what's going on in this picture, and he has overlaid that. If you think of an overhead screen, I'm going back a couple of decades, but an overhead screen, when the teacher would put the clear plastic film on the screen, and then she or he would write on it. That's exactly what this professor does at Albany. He'll take a photo, and then he'll write on the photo exactly what's happening meteorologically, so that the students understand just the concepts that are going on. And really good feedback on that, in terms of, wow, this is great now that people know what's going on, not just looking out the window and seeing the rain coming, that you can actually say, okay, these are the processes behind what you're seeing right now on the camera. So that's really cool to be able to do that. And and when we do give talks to students, one of those things that we kind of focus on is, okay, and I give a talk, I show a picture, and then I walk through exactly what's happening in that picture, and I say, this is the science behind what you're seeing. It's not just a thunderstorm happening. It's, okay, this is why there's a thunderstorm in this picture, and not, if you look to the left, you see sun, which means it's not too cloudy, which means you don't have a lot of updraft, which you have mostly downdraft coming in the picture ahead of you, which is where all of this rain's coming from. And the Seneca Lake, even though it's not too big, it is narrow. And so when you have something coming down the lake, it'll just squeeze it and push all the rain down. So things like that the students really get involved in. And depending on the level of class, determines how much science we provide. So, I wouldn't give the same physics reason to grade 6 and 7 general science class as I would to 11 and 12 physics class, for example. We've had some biology classes that we've spoken to, and with the biology, we actually take all of the rodents and other insects that we have found at sites, and we show them pictures of where they happen to be upon arrival to the site. And so, that gives those students a little bit of an issue as well. Yeah, you know what? I didn't think that mice could live any place, but yes, I think they can, to quote one of the students that we talked to. And so a lot of the Mesonet data we use is for universities and for research, but I'd say 40% of it is used when we give talks to students at different schools. Be it here in New York, which we have obviously the highest pull from, But like I said, we've also given talks to students across the country. And so we really just want to get everybody involved in the fact that we have this data, and we can tailor it to teach whatever type of topic you want. I mean, it doesn't have to be specific meteorology. Like I said, we could do physics. We've done that before. We've done biology, and of course general science. Depending on what level the school is. We have at the schools that we have sites in. So we have 4 of them, like I said, and each of those schools every year they do a science project based on their own school Mesonet data. So the science teachers they'll get together and they say, okay, we want to do a project on this. And so when that project's done, the field tech of whose sites that is, so I've gone to 3 of them. It's really cool. The kids, I go and they present them data to me and to their other classmates. So it's a lot of fun. It's really cool. And some of the kids are fantastic. I mean, a lot of times you wonder where the kids got these ideas and fantastic projects from. But it's a lot of just connecting between what they're taught in school and what's happening outside the window. So there are different facets, but the general idea is that we do want more students to use the data. We need the feedback from you guys in terms of teachers to say, okay, what types of programs do you need? I know Neil mentioned that there was curriculum change in the science. We need to know that so that we can help you guys out in terms of if it would help you guys in a lesson. If you're teaching a lesson and you say, well, you know what? I really need someone else to talk because my kids have been seeing me on Zoom too much. Or I think some of the kids would get a huge benefit out of somebody else really in the field who deals with this information and who deals with science on a daily basis. They would glean a lot more than if I were to do it on myself. Not that you couldn't do it, but just that one other aspect, maybe it'll sink into someone more so. You guys have any questions? I know it was a lot, and I know we zoomed for a long time. But yeah, if you have any questions, I'll put my info down in the chat box. Let me get there here.
Are teachers able to access the Mesonet data?
Yeah. So so educational institutions can access the data either free or for an extremely reduced cost. So the main website is nysmesonet.org. And so scroll down to the bottom and it says something to the effect of how do I get the data or what's the data? So you can access the data. Just to give you an idea, we collect the data once every 5 seconds. And so if you prolong that out to a whole day, that is a whole lot of data. So just to let you know, if you do want to request it, be very specific on what data you would like. Most of the students who request data, they do request it for a day, at the most 3 days, because that's just a lot of information, a lot of numbers to crunch. But you can say, I only want the rainfall data, or I only want the wind data, or I only want to see how hot it was on these days. That's entirely possible. We had one student, she is currently at the University of Wisconsin, and she and I have been going back and forth, and she took all of the data from the 2-meter and 9-meter thermometers from 7 stations that she chose it randomly, and she is now using that as her PhD studies talk to decipher how does she put it? She wants to know the wide range of temperature variability at each site in a 4-year period. So she's taking the data from 9-meter and 2 meters and seeing how much those change between themselves at a site, which I think is cool. But anyway, so that's an idea of what she's doing, and with our data on a much higher level than just elementary school kids. But that's gives you it's a wide range of what she can do. I believe because of COVID, I'm going to be able to zoom in on her thesis and watch her do her thing, which is cool. I think it's neat. But yeah, and that's not going to happen until the middle of January, incidentally, because of COVID. Yeah.
I was looking at that data request form. So as a high school teacher in New York State, if I wanted to use some of that data for a project, would there be a fee? What type of cases would there be a fee for requesting data?
Right. So, yeah, good question. So the reason I say it is because the only time a fee would be charged is if you took the data that you obtained and turned around and said, I'm going to quit teaching. I'm going to go into a science-based job. And look, I have all this data that we can use to grow the company. Does that make sense? I don't want to.
It does. Okay. And what,
Yeah, go ahead. Yeah.
and the other question was, like, what is the turnaround for that data? So if I'm doing a project and the students want to research something and I fill that out, how long approximately would it take for, if we're looking for like part of a day? Maybe a storm came through, we wanted data for like a 2 or 3 hour period on a day.
Yeah, great. Yeah, so I didn't touch on that because it's kind of a loaded answer. We only have one employee who is able to send data to people who request it, and thanks to COVID, the requests have grown exponentially. That being said, if it's if you want just half a day of information, or if you want just a storm, say we get a storm Saturday and Sunday, you say, I just want Saturday and Sunday from Lawrence and Sherburne and Deposit and Owego and Cincinnatus and up towards Chobani. What's that one up there? Brookfield. If you just want those sites, there's 7, 8 sites in just a 2-day period. The turnaround time would be pretty quick. It'd be about 2 to 3 days. And I say that because even though we get the data, we quality control it, and we send it out. So that quality control time takes half a minute to 3 minutes. So it's not that long, but we still have to have someone physically look at it. And so I look at it and I make sure it doesn't fall through the cracks. But I would say 2 to 3 days. Like, it really isn't that long of a waiting time. Josie's really good at getting the data out to people who request it, especially if you say, hey, I'm a teacher and here's what I'm going to use it for. I would say be really specific on what you want and why you need it. You can also put my name down. That's fine too, because then she'll say, hey, okay, I got it, that type of thing, so that that she knows exactly what you're looking for, that you're not just saying a blanket umbrella. I would really caution on saying, I want data from December 1 to December 29, all the data that you have. That would be insane. We would actually come back to you and say, okay, what are you doing with it? But if it's a short 48 hours, yeah, I'd say 2 to 3 days. Yep. Josie's really good at getting that out. Yeah.
Thank you.
Thank you, Dan. I think all this stuff is fascinating. I don't know. I appreciate you being willing to do this. I do have it recorded, so we will send it out to our science network, and hopefully more teachers will be able to pick up on it from there.
So yeah, just before we leave, just to give an idea of other projects we have going. I guess that we do help not just the general public and the guys who own the sites and stations on, but we have a project with Con Edison. We help them figure out straight line winds, which can be mistaken for tornadoes. This one happened up in Sherburne, outside Norwich, just a couple of years ago. I had to go out there and take a bunch of pictures from the National Weather Service. But basically what I'm going to say is when we give these talks, we take the data that comes straight from the station, and we say, okay, look, as a scientist, I'm going to take this data and I'm going to use it this way. And I say, well, and I walk through the steps of how I determine, okay, you know what, it wasn't a tornado, it was straight line winds. And when you guys drive up Route 12, just before you hit Norwich, you look to your left in the wooded area that's owned by the city of Norwich for the water treatment, you will see this. This is all those trees that went down. This is a straight line wind damage that caused those trees to go down. So that's a real application. But obviously, you can only really do that the best with a school in Norwich or a school in Sherburne Orville or in Morris. I mean, you can't be that local, but still, I use it to tell kids this is how you do it. A while ago, I mentioned about the eclipse, and this is just one station. This is out in Addison, just south of Corning, New York, and this shows exactly when the eclipse happened at that station. You can see at about 2:15, we saw the radiation watts per meter drop from 251 to 90, and then at about 3:05, oh look, it comes back up. So that's a clear-cut example of not just a cloud, but this is just one site that I said that we can see the eclipse move across the state. And so again, this is something that the students can take a look at and say, holy cow. I mean, I know it was August and a couple of years ago, but maybe some students might remember that. They went outside, they looked at the sun through the cardboard glasses and such. But again, it's kind of a real application. And then, as I mentioned, these are wildfires in California that moved east. You can see that, some of the Mesonet data stations dropped their temperatures pretty quickly. We had a 3-day span where about 5 degrees lower than that same time frame in years past. Solar radiation went down, of course, because everything was clouded up, and also the temperature drops. You can see the thin blue line is the solar radiation dropping on the 14th of September. The temperature is not that apparent in this shot, the graph here, but this is getting back to the graph of the freezing fog, just to show that there's a lot of things you can pick out, and then there are also some things you cannot pick out. Like you would not know that the temperature on those days at this site was lower on those days because of the wildfires than previous years, because you can't tell that from the graph. That's kind of one of those things where what can you tell from the graph and what can't you tell? Again, this is just another site a bit farther west than Jordan, but just to give you an idea of what we do. And then closing up, we've got throughway sites. They're much different than the regular sites, but they do help. Their focus mainly is snowfall, lake effect snow, if you could imagine that one being out west. Shot of the sites here. We have 9 sites out west, stretching from the PA state line up to just south of the city of just in the city of Buffalo, by the sign. And then 2 out west, 3 out west. East of there in Syracuse. There's one in Canastota by the Boxing Hall of Fame. There's one on the Liverpool rest area as you head east on the thruway. And then the other site is dangerously in the median of the thruway. So, and here's just a regular shot of the site down by the PA state line. That was taken this morning. I think I snapped that this morning. So, again, we're just trying to get everybody the notice out that this data is available, and we can walk you through how to get the data. We can walk you through, now you have this, what do you do with it for your students? We've had various civic organizations pay for the data because they need it when they have to do the function and for insurance reasons. They've said, hey, look, we lost a tent because of the high winds, and we had this measurement data to back it up, and the insurance company said, okay, you do. So, that's a non-school thing, but trying to get notice out to people that this data is available and it can be used, as you guys see fit.